Okay, so I will be starting this discussion with something called by the name of simple attribute system. Let us try to understand this very simple concept called a simple attribute system. So I am having a pulley like this. Okay, so this is the pulley that I have. Now I have two strings, a same string is going around it and it is attached to two masses over here. So this is the masses. Okay, these are the masses. First assumption is pulley is massless and frictionless. Okay, right. So this is the basic assumption over here. Now this is the pulley by which it is going. So that means the torque acting on the pulley is equal to 0. Why? Torque is equal to I alpha, isn't it? Now if mass is equal to 0, then the moment of inertia is also equal to 0 and the torque acting on that is also equal to 0. So this is m1 mass and this is m2 mass, and I am assuming m1 is more than m2 and there is the mass of the string is also equal to 0. That is also an assumption that is required. Now let us make the free body diagram for this. See, whenever you are having unequal masses, whenever we see that the system is actually accelerating towards one particular direction, then we take the net force and then we will be equating it to ma. Okay, so that will be equated to m into a. So here if I just make the free body diagram of m1, then that is m1 multiplied by g. This is the weight of m1 and this is the tension force that is acting over there. Since the pulley is massless and frictionless, the same tension will be going across this, and this is the tension. So tension across the pulley will be the same provided the mass of there is no mass and no friction for the pulley, right? So this is m2 g, and I say that the acceleration is towards this side in case of m2. The whole thing is actually moving in this particular direction. Okay, so it is very much convenient for me to write the equations now. So if I consider m1, I will say that more is m1g than t. So this is m1g minus t is equal to m1 multiplied by a. So more is m1, less is t. So m1 is equal to a. Why did I say m1g is more? Because m1 will move towards that force which is more, and it is m1 is moving in this particular downward direction, and the force acting towards the downward direction is m1g. So m1g is more. So this is my first equation. Now my second equation will be centered around this m2. m2 is going upwards, that means tension is more here. So t minus of m2g is equal to m2 multiplied by a. So we have two equations and two variables. Two variables are t and a. Just solve this. We have been solving this since every time a teacher comes to the class to take the concept of laws of motion, he or she will definitely teach you this kind of an equation. So there is no need of further explanation on how to solve this. So a will be equal to m1 minus m2 by m1 plus m2 into g. So this is something that we all learned, isn't it? This is a by heart. These equations are by heart for us. Now t is equal to 2m1 m2 divided by m1 plus m2 multiplied by g. Okay, these are the two important equations that we are supposed to keep by heart. But obviously, no matter whichever important equation you are keeping by heart in physics, you are supposed to know the derivation for those, because this derivation will help us to understand physics in a better way, and our way of approach to physics will definitely change, because our understanding of physics is as such increasing. That it will actually condition our understanding of physics in a great way, that any question which is asked in the physics after that will be very much easy for us to understand the concepts, at least because we are learning everything in a very conceptual way, giving adequate importance to the derivations as such. Okay, so I am just going to modify the situation in such a way that I am now having a inclined plane like this. This is the next modification that I can make over here, and this inclined plane has inclination theta on both sides. Okay, so this is an inclination theta which is equal on both sides, right? So I hope you can make this out now, and I am keeping my pulley over here, and this is my m2 mass, this is my m1 mass. It's a little difficult to draw with a drawing tab for a non-artist like me, but yes, I will be making this out somehow. This is m2 and this is m1, and obviously we know that this force is m1 g sine theta. So this is also equal to, this will be equal to m2 g sine theta. Again my assumption is okay, that is the pulley is massless and frictionless, so the tension across the pulley will be equal, and that will be T. Now, why did I take this as m1g sin theta? If some of you might not be knowing this, then I can just explain that very easily like this. See, this is m1g, isn't it? This is the weight of the mass m1, which is in the vertical direction. Now, I am splitting this into two components. That is, one is m1g. This will be again theta. You can prove this geometrically, cos theta. And this is m1g sin theta. So the force acting is this, and I am saying that the acceleration is towards this direction. So m1 is moving along the acceleration. So I can say that m1g sin theta is more minus of t is equal to m1 into a. Now in the other one, that is t minus m2g sin theta is equal to m2 into a. Right? Again, you solve this question with the help of two equations, and I can understand a is equal to m1 minus m2 into g sin theta upon m1 plus m2. Okay, so this is the only modification we have in the previous question. Here a sin theta value is also coming. In the one and the previous one, it was m1 minus m2 by m1 plus m2 into g. But here it is m1 minus m2 by m1 plus m2 into g multiplied by sin theta. Now let me tell you something. Just assume that theta is equal to 90 degree. So if there is a condition, if I am going for a discussion of 90 degree is equal to theta, then a is equal to m1 minus m2 divided by m1 plus m2 into g, right? And sin theta will be equal to 1. So what has happened over here? If theta is equal to 90 degree, then this is how it looks like. Now this much big one is the theta, and that will be equal to 90 degree, and your mass m2 is actually vertical. Similarly, if theta is equal to 90 degree in this direction also, in this particular part of the image also, then my mass m1 is vertical and my pulley is over here somewhere. So this is actually going across the pulley. So that means it is, I have just derived the equation. For the previous condition. Okay, so I have just derived the equation for the previous condition. So what has happened over here is that this is the basic discussion. This is the main equation, and this is a condition that is coming in the second equation, right? I'm hoping you that you are getting this kind of concept over here. That this is what is going to happen when sin theta is equal to 90 degree. Then what we are left with is this kind of the same condition will come when sin theta is equal to 90 degree. Thus we get the equation over there, right? So that is the first part of pulley based discussion. Now we'll proceed to further more discussion in which we are keeping on modifying the situation one after the other. Modify the question again, and if I again modify this, what I'm landing up is the topic of system of particles and rotational motion. So this is the modification that I can do now in this kind of a question. So this is the same pulley, I mean a different pulley now. This pulley, the only difference with the previous pulley was that this pulley is having a mass m. So I can say that the moment of inertia of the pulley is I and the radius is r. Remember, this is not a massless pulley. From now on, we are talking about a condition where the pulley is massful. Okay, this pulley is having some mass. So I can say that the pulley, mass of the pulley is m, and therefore the moment of inertia is I, right? So I can just tell you what is happening over here now. This is m1g, this is m2g. Now, since the pulley is having a mass, there is moment of inertia possible. So the torque of the pulley will be not equal to 0. Now let us understand that if there is tension T over here, and if the same tension was happening here, if the tension on both sides is T only, then the same tension will act on the pulley in this way, isn't it? Now if two forces which are equal acts on a rotating system in this particular same direction, will the pulley rotate? It is very easy to conclude that the pulley will not rotate. The pulley is now having a mass. Since it has a mass, to rotate it requires a torque. Who will provide the torque? The tension will provide the torque. But tension is acting on both sides. The tension is acting on both sides, and if the same tension is acting on both sides, then it is just like pulling the entire pulley over here towards the bottom, isn't it? From both sides. And that will not rotate the pulley. For pulley to rotate, one of the tension should be more, right? So I say that here M1 is more than M2. If M1 is more than M2, then here the whole system is accelerating downwards. That means the pulley is rotating. That means the tension on both sides of the pulley are unequal. This is the first concept that you are supposed to understand, that the tension on both sides of the pulley are unequal because the pulley is rotating, because the pulley has a mass, because the pulley has a moment of inertia, and therefore the torque will be not equal to 0. There will be a torque, and it is this torque which is produced by the tension acting on the pulley which is going to rotate the pulley. Right? So I will have to mark this as T1, I will have to mark this as T2. The same tension will be acting over here also. Okay, tension is always acting away from the body. Tension is always acting away from the body. Now it is very easy to write the equation. So the first equation that I am going to write is m1g minus of T1 is equal to m1 multiplied by A, because the whole system is accelerating downwards. Next is actually T2 minus of m2g is equal to m2 multiplied by A. Okay, and the third equation is T1 minus of T2. Why? Because the pulley is rotating towards this direction. So tension 1 is more than tension 2. That is why this is pulling more towards the other side. That is why the pulley is rotating towards this side. Now, what is the force responsible here? That is torque. Okay, this is T1 minus T2 multiplied by R. R cross F. R cross F. Okay, sine 90 is equal to 1. The angle between the tension and the radius is 90 degree. So therefore, T cross R, R cross F is equal to I alpha, isn't it? Torque is equal to I alpha. And since there is no slipping here, alpha is equal to A divided by R. So this is A divided by R. So I can say T1 minus of T2 is equal to A upon R square. So this is the first equation, this is the second equation, this is the third equation. This time I am going to solve this for you. See, what I will do is that I will be taking T1 to the other side. Okay, I will take T1 to the other side and then add. So what will I get? M1g minus of M2g. So that is M1 minus of M2 multiplied by g is equal to M1 plus M2 into A. M1 plus M2 multiplied by A. So this is how I am solving this, into A plus of T1 to the other side, that will be plus T1. This T2 I am taking to the other side, so that will be T1 minus of T2. So in place of T1 minus of T2, I will be substituting A by R square. So from here the acceleration directly comes out to be m1 minus of m2 into g, okay, divided by m1 plus m2 plus of I divided by R square. So this is a very important equation. If at all they are giving a question on the pulley, they will be saying whether it is a ring or a disc, whatever it is, you can substitute the value of I as per the question that they are giving in the exam. Okay, so this is how we are linking the concept of pulley to the topic of rotational motion. So whenever this pulley is having a mass, it will have a moment of inertia. So the torque will be non-zero. If the pulley is rotating, it is because of the torque, and who is providing the torque here? The net tension is providing the torque over here. Okay, so only then we can understand and we can apply the concept of rotational motion in this question, right? Okay guys, the next kind of modification is the same modification that we have learned in the previous example. I am having an inclined plane on both sides. So the inclination on both sides is theta. This is the pulley, but this time the pulley is having a mass, right? This pulley has a mass, so the moment of inertia is I. The radius is R. So this is my mass M2 and this is my mass M1. And that is attached to the pulley with the help of strings over here. And as I said, the tension across the pulley will be unequal because the pulley is having a mass, it is having a moment of inertia. So this is T1 and this is T2, and this will be M1 G sine theta, and this is the M2 G sine theta, right? So what will I do is that when I try to solve this kind of a question, again, if you go and solve this question, I will be getting the value of acceleration as m1 minus m2 divided by m1 plus m2 plus I upon r square multiplied by g sine theta, right? So this is the equation that I will be getting once I solve this kind of a question also. So how can I link this to the previous one? When sine theta is equal to 90 degree, when this is equal to 90 degree, then my m1 will be vertical. When this is equal to 90 degree, then my m2 will be vertical. So that means I am simply getting the previous question itself. So this is the condition where the theta was equal to 90 degree. So yes, this is a modification of this is a condition that is arising with this particular formula itself. Right, so we have mentioned 4 different kind of questions over here. You can get any of these questions in the exam. Now we will take another video in which we will be solving questions, more difficult kind of questions that I have taken from H.C. Verma's textbook. So we will be solving some of those questions over there to understand these questions, the concept of Pulley in greater detail. Thank you.